Hey guys, my name's Colin Nugent, and today I'm going to be talking about post-processing effects and rendering. So before we get started, I'm just going to give you a quick overview of what we're going to be talking about today. So first, I'm going to give you guys a more in-depth definition about post-processing effects than the last talk I gave, and then I'm just going to go over a variety of effects that post-processing can entail. Okay, so what is post-processing? So post-processing is a step in the rendering process at the very tail end in order to add additional image quality improvements or filters to a rendered image. Now this is after the entire scene is created and all the objects in the entire image is rasterized and ready for additional effects. So all the lighting, basic lighting effects are calculated at this stage and can be tweaked with these kinds of effects. Now, there are a couple of ways that these can be applied or interpreted. So, post-processing usually has two categories that can be used to apply effects. One is to replicate real-world lighting effects that are a bit more in-depth than the basic lighting calculations that are done in the very first stages of rendering. And then another type of effects mainly include simulating effects that are given by a camera. So, whenever any behavior that a camera lens can exhibit. Both are used to create real world effects into an image. Now, pretty much all of these involve lighting improvement. There are a couple of exceptions, but a majority of the effects I'm going to be talking about today do involve lighting effects. And all of these can actually be applied in engine. They can be applied hardware at the hardware level or the software level. So hardware would be in the case of graphics cards and real-time rendering, and software can be mainly applied in pre-rendered images or also in real-time rendering with a couple of software programs, one of which I'll be giving an example of with a live demonstration later in the presentation. So next we'll be going over a couple of effects that post-processing can cover. Okay, so the first effect we will be going over today is bloom. Now bloom is a very great one to start off with because it's a very simple effect to understand, it's easy to implement, and it has very low performance costs, which is a great effect to start out with when compared to the other effects I'll be talking about today. So the general purpose of bloom is to simulate the real world behavior or the camera based behavior of objects that bleed light when hit with direct rays from a light source, be it sunlight or any other source, which is actually the most noticeable when viewing. This effect is more noticeable viewing actual light sources like, say, a lamp or the sun. So all it does is checks to see if an object is being affected by a light ray. This can be tweaked to see if it's more direct or it's a bit more subtle, and then it takes the object that is affected by the light source and the light that is hitting it. At the edge of the object, that lighting effect is blurred a little bit to give it more of a glowing effect. Now this is extremely easy to implement because it's basically just a quick check and a blur. This can be used as a Gaussian blur or any other type of blur that the software renderer would like to use. Now, this doesn't have to exactly only apply to objects. It can also be applied to camera overlays and filters, such as, say, raindrops on the camera or, say, sand particles. That can be affected by bloom as well, emphasizing the camera effect. All right, so the next effect that we're going to be talking about is depth of field. Now, depth of field is similar to bloom in the fact that it also involves a blur, but instead of involving object lighting, it involves every object in a scene and involving the camera. So depth of field's purpose is to replicate the effect of focus, in which certain objects are focused in a view while others are not. This is used in both the human eye and in real-world cameras. So depth of field blurs every single object in a scene based on its relation to the camera. So how this is done is, if it's pre-rendered or in real time, each object in a scene is placed into a group. Now, there are usually three groups. There's a near group, a far group, and a focal group. Now, once all the objects are placed into said groups, based on what group it's in, it will be blurred in relation to the camera. And this can be dynamically adjusted between each object. So near and far objects are pretty much always going to be blurred. Some may be blurred a bit less than others, but both will be blurred. The focal group is the center and the main focus of the camera and will not be blurred. So this is to emphasize focus on certain objects and keeping other objects out of the main center of attention. Another post-processing effect is ambient occlusion. Now, ambient occlusion is different from the previous two, not because it's trying to simulate a real-world effect, but it is trying to simulate something that isn't really achievable right now in an efficient way, which is global illumination in the context of real-time rendering. So what ambient occlusion does is provide additional shading rather than just basic shadow projection for objects in order to simulate the idea of global illumination. So instead of specifically projecting shadows, what ambient occlusion does is determines wherever on an object light does not reach and shades it accordingly. So this provides additional depth for objects outside of basic shadow projection and simulates ambient lighting and ambient shading. Now, this is usually calculated on a per pixel basis for each object. There's also a couple of different implementations that AO has. One of them is SSAO, which is the exact same thing as ambient occlusion, but in order to actually calculate the shading for each object, it calculates each pixel distance in relativity to the z-axis in the entire screen space. Depending on how deep it is, it will provide the shading required for that. Two others are HBAO and HDAO, which are more advanced versions of SSAO, but are more hardware specific, with HBAO being mainly used for NVIDIA graphics card systems, while HDAO is primarily optimized for AMD GPUs. The last effect that we'll be talking about today is subsurface scattering. Now, subsurface scattering is a bit more specific than a post-processing effect like ambient occlusion in the fact that it only really affects a specific set of objects. So what subsurface scattering is attempting to replicate is light behavior when going into an object and either passing through, being absorbed, or being reflected back from an object. So this really involves objects and textures that include, like, say, paper, wax, and most importantly, human skin, which is the central focus for real-time rendering subsurface scattering effects. Usually in pre-rendering, this is done with actual light rays and tries to replicate the literal physical properties of light, but that still isn't fully realized in real-time rendering just yet. So instead, subsurface scattering techniques involve approximation of light data, which can be used in a data structure like a light map, which essentially holds all the lighting information for any given object or texture and can be retrieved later for lighting calculations. So based on that, you can tweak the light maps to basically replicate the certain light behavior of different types of objects, and based on the translucency and the actual depth of the object, you can replicate the effects of subsurface scattering, allowing light to come into the object and reflect outwards. Now that I've pretty much talked about all the rendering effects that post-processing can entail that I want to talk about, there are actually a lot more overall uses that post-processing has in other applications than, say, either pre-rendering or real-time rendering. Post-processing is all about image enhancement. So it can even apply to things like color filters or any other type of lighting filters. Bloom is an example that is used in very common things in image editing. Like Photoshop is a big one that pretty much thrives off of image editing and can use a variety of post-processing effects. And then social media apps like, say, Snapchat or Instagram really appreciate the use of filters to enhance images and videos that people post. So they're not really that intensive compared to the ones that I've given today. So things like basic color filters are very useful in terms of social media applications. If we want to go a bit deeper into post-processing, similar to making fake images in Photoshop, deepfakes really benefits from things like post-processing. So deepfakes, in summary, is essentially just trying to remap someone's face onto a pre-recorded video in order to mimic the appearance of that person giving the exact same speech or same talking patterns. Post-processing allows additional effects to be implemented into the video in order to actually simulate a more realistic version of lighting in that context, as opposed to the original sampling used from different videos and different pieces of data that the algorithm uses in order to replicate someone's face. So that can make a lot of situations that deepfakes already finds trouble in a lot less difficult, meaning that it's a lot easier to replicate someone's facial expressions onto new videos. And that's pretty much everything. But before I conclude the presentation, I'm just going to give you a live demonstration of some of the post-processing effects I've talked about today. So the cool thing about post-processing is there's actually a lot of ways to implement it outside of the actual game engine in terms of real-time rendering in games. One of the ways you can do this is actually installing third-party software programs that inject these effects into the game for you based on the game's operating system and its engine. So the example I'm using is the Resident Evil 2 remake. Don't worry, there's no zombies in the rooms, even though it's rated M. No one's going to the principal's office today. So the program that I'm using is Reshade. This is a pretty great program, I'd say. It has a lot of options and presets that the community can make in order to improve the game's color and overall presentation. So I'm just going to give you two examples, bloom and depth of field. These are pretty much approximations. They're not really the most optimal, but it's a great way to show you the comparison between two objects. Now, bloom is off in my game settings, and the example I'll use is bloom and lens flare. It's just a random bloom effect. Now, as you can see from the lamp, it is emitting light, but there's not really any blur. But with bloom and lens flare, it's a pretty good approximation of the bloom blur. Maybe it's a Gaussian blur, I'm not entirely sure. So you can see it with it on versus it off. It's pretty simple, but it's nice. And then the last effect I'll show you is depth of field. This is extremely rudimentary because it doesn't really approximate everything correctly. So I'll just use cinematic DOF as an example because I feel that it actually includes the near, far, and focal groups rather well. So here's depth of field off, and then the experimental DOF is on. Now, as you can see, objects near the camera are blurred. Unfortunately, Leon's blurred, which is kind of sad, but that's pretty much how this program decides to pick and choose what is blurred, and pretty much everything around the middle region of the camera is not blurred. Say this fan, and as I move closer to this lamp, it is not blurred. And the far blur is probably the least pronounced because it's rather far away. I think mainly the purpose of this DOF effect was to mainly blur the near focal group. Alright, so that is pretty much it. And alright, that concludes my presentation. Here are the sources that I used for my talk. If you guys have any questions, feel free to either ask or comment in the YouTube comment section or on the Blackboard discussion post that I will upload once this is all uploaded. And feel free to just ask any questions there. So yeah, thanks for listening.